area of a triangle formula. You know, generally, if it was a right angle triangle, what's the basic formula that you used when you were in middle school, like year 7, year 8, year 9?
So base times height over 2.
Yeah, exactly, base times height over 2. So when it's a right angle triangle, the fastest thing to use is base times height over 2. You can actually use this one, to be honest, because if it was a right angle triangle, you could put in 90 degrees. And anyone want to guess what sine of 90 might equal?
1.
1? Yeah, good, 1. Which means that you've got your base times height divided by 2, or half base times height here. So if it is a right angle triangle, you can use this as well, because you would put in sine of 90 and then you would get 1. So, but if it's a non-right angle triangle, you kind of have to use this formula, because according to the base times height divided by 2 formula from middle school, the base and the height have to be at right angles. They have to be perpendicular. But if someone's come up with a rule, there is a proof for it. But what I thought I'd do is I just go through the rules, and then so then you can have time, you know, the rules to work on the topic assignment, and then we can do the proofs as an afterthought kind of thing, rather than take up lots of time doing the proofs now and it taking longer to get through the basic stuff. But yeah, the proofs are good. The proofs are just using SOHCAHTOA and Pythagoras. It's quite interesting how you can prove these rules: the sine rule, cosine rule, and this rule. Okay, so one important thing is the angle has to be the side in between, has to be the angle in between the two sides. What's a fancy name for that angle? The angle that's between two sides?
Inclusive.
Yeah, the included angle. That's it. Yeah, exactly. So it must be the included angle. Is a good kind of way of describing it. So it must be the included angle. The included angle, e.g., you've got to have you have your A, B, and the C has to be that angle. So if we give you the other angle, like if we give you a different angle, you would have to somehow calculate that angle instead. So maybe if we gave you these two angles, this one and this one, then you could just do 180 minus those two to get the included angle. Alternatively, if we gave you that angle instead, let's say this one, the top angle, and maybe the bottom angle. If we gave you the bottom angle instead, you might need to use some of the rules to, like a sine rule, cosine rule, to find the included angle, or find one of the other angles and then subtract from 180 to get the included angle. I've just given you some basic ones because you're pretty good with the sine and cosine rule already, so I thought I'd just go straight to some ones that you can actually get it from. So I see it's half AB sin C. Sometimes people like to just call it 0.5 AB sin C in the calculator. So it's nice and easy. I don't even bother labeling like A, B, C or anything like that. I just realized that the two, according to the formula, the two lengths, it's a half or 0.5, and the two lengths multiplied by each other, sine of the included angle. I just go straight to putting that in. So sometimes when I'm doing my working out, I might do a half or I might do 0.5 and just put in 18, 20, doesn't matter which order you put them in because they're multiplied. Sine of 54. The only kind of errors that can pop up with this kind of thing is you might be in mode radians when it should be degrees. If it's in degrees, just make sure your mode on your calculator is in degrees and not radians. Another error is sometimes people just randomly forget and put cos there instead. But there is no area formula with cos in there. It's always with sine. So if you're in doubt, just look in your formula booklet because it's in the formula booklet. If you forget exactly whether it was cos or sine that you pop in. And then it nicely goes in the calculator. You know how to make nice fractions, so you could go alpha y equals and put in a half. If you're in a rush, I just put 0.5. I put 0.5 brackets, 18, close bracket, open bracket, 20, close bracket, sine, whatever that thing was, 54. Okay, who got a little answer? An unknown answer.
3, 4, 5, 6, 2, 3, 0, 5, 9.
Awesome. And 3C6.
146.
36, yes. And what would be our unit? Good guess?
Meter squared.
Yeah, it feels like an angle, doesn't it?
Like, isn't a capital A?
Ah, that's a good point.
Oh, sorry.
Yeah, but that's a good point. I didn't think of that. That could be something that could be, like, you know, it's the area, yeah. And that's something that could happen is our brains are kind of like getting all fuzzy after being fatigued and doing 100 questions in an exam or a test. That could happen, so that's a good point. So the big A in this case is standing for area. So what would be the unit? Sorry, just
Meters squared.
yeah, meter squared. And Sarah's got a good point. Capital A, what often would mean angle A. So that's something to sort of double check. Just going to quickly calibrate again because it's gone. And the questions I've given you are pretty straight up ones. More challenging ones would be when they want you to, they give you the area and they want you to transpose, rearrange and solve for
You
it.
gave us that net.
Yeah, this one's not, but I can make one up at the end for you. That'll be easy enough.
What this one, the second one where you give us the areas.
Oh, do I?
Yeah.
Oh, great, good. I didn't realize that. I just saw the picture. I didn't see that it was an X, and I thought, oh no, I've given the sides. Great, thank you so much.
Oh my goodness.
So this is a nice one that I was just talking about I didn't have. So here we give you the area already, and we want you to rearrange, use a bit of transposition, and you're going to solve for the unknown side x. And the good thing is notice 45 is the included angle, so that's great. We don't need to calculate any of the other angles. We've got the included angle, and so on. So you might want to just plug it all into the little formula. I tend to go 127.3 equals, get my little method marks. A half, you can put 0.5 if you want. A half, 45. If you like, just put x in a bracket or just leave it without a bracket if it looks okay. You can put a half stack of 45x. But if I don't put the x in a bracket, I kind of miss it sometimes. And then the sign 45. I'm just in the habit of putting the two side lengths in a bracket, even if it is x.
Wouldn't it be a half 18?
Oh my goodness, thank you so much. Thank you, Sarah. That would make a lot more sense. Which would be the length. Hey, let's practice doing this one. Well, because of that awkward number, we might not be able to do it easily non-calc. But out of interest, a little bit of review. Sine 45, 3. Yeah, what is sine 45 equal to? Remember special angles? Because we've got a 45.
Sine 45 is like not a nice number. Yeah.
Let's see. So with the special triangles, what were the on a 45-degree angle? What were the special lengths on the? Yeah.
One root 2.
3. Yes. 1. You can use Pythagoras to work it out. Yeah, root 2. Yeah. It'll be the square root of 1 squared plus 1 squared, square rooted. Give you root 2.
Did you just not hear me?
So sine of 45 is opposite over hypotenuse, which equals
1 over root 2, which is root 2 over 2.
good memory. Which is root 2 over 2 because remember it's a bit yucky to have a third on the bottom. On the denominator, it's just an old thing that's hung around from the non-calculated days. So times by root 2 over root 2. This is just good practice of these things. So as we mentioned equals, what is it? Root 2 over 2. That was just a nice opportunity to work those out. If we had a nice area here, like there wasn't 127.3, it might have been a nice one to work out by hand. Do you want to try to work it out without calculator for now? No? If you were to work it out without calculator, what would you do first? There's multiple things you could do.
Do half times 18. Multiply.
Yeah, that's a good idea.
Multiply 2.
Yeah, you could do both things. So Sarah's way, in her mind, she would think, okay, half of 18 is 9, so she would change this to a 9. Or as Kiesha said, this fraction's a bit annoying, so deal with it by doubling the other side first, doubling 127.3. Both would be good. So you guys feel free to pick your own path, and hopefully we'll get the same. I'm doing it non-calc, but this would not be non-calc because of the awkward numbers. If they had nice numbers here, then that would be non-calc.
Why did you do this before?
and cool. So you could kind of like start to sub that in instead, but that's kind of awkward, isn't it? So, oh gosh.
If you rewrote the equation, so you have x equals
Yeah.
x equals 127.3 over 0.5 times 18 times 1045. Would that be how it was?
Oh, if you rearranged it right from scratch, like did it all the transposition in one lovely step.
Yeah.
Yeah. That's right. It'd be double this, divide by 18 sine 45. Yeah. So yeah, if you did it in one big chunky step, which can be a bit risky, it would be 2 times 127.3 divide by 18 sine 45. If you did do it in one big chunky step. So you would double. You could also think divide by a half. Divide by a half is also possible. So you could have, some of you might have had 127.3 divided by 9 for sine 45. That's the same thing. So you could have times by 2 here, then divided off the other things. Or you could have times that, make it 9x sine 45, and then do 127.3 divided by 9 sine 45. X equals, what's our unrounded x, or do we get a nice number? Probably not.
20.00326516.
Cool. Let us know if anyone disagrees. What would that be, the 366?
It's not me. I did it the way that you have in purple, and I got 10.00.
Oh my goodness.
I got 20. My calculator just
Did you use that alpha y equals to make the fraction? Silly?
I didn't either, but I got.
Yeah, the fractions, if you get an awkward fraction like this, doing the alpha y equals is much safer. Otherwise you can get BEDMAS issues. So 2, 127.3 over 80. Oh, and double check your mode is right. Double check your mode is degrees Celsius. So it's probably the alpha y equals. Yeah, this is the right number. Yeah, so that's interesting, showing that if you didn't use your alpha y equals to make a nice fraction, you would have gotten a different answer. So useful, that would be. So this is a nice number, 20. What's wrong with my answer?
You didn't go 20.0
Yeah, exactly.
and use it for.
It would be units because we're not finding the area.
Yeah, be very conscious of the units, yeah, because our brains, there's so much mental cognitive work going on that it can frazzle you, and you don't want to then just lose a mark for a unit, something as small as a unit after you've done all that high-level thinking. There's that, let's save that. Yeah, so this stuff on the side was more just to revise, like review your special triangles. If I gave you nice numbers, like if I gave you something like 900, if I gave you something like 900 here, we would have been able to potentially do this non-calc. There's 900, and then we would have doubled it to make 1800, then divide by 18 would have made 100, and then 100 equals x sine 45. We would have then had to times by 2, so 200 equals root 2x, and then 200 divided by root 2, and then rationalize the denominator. Okay, next one. Find the area of the following triangles, determine the area. These are two straight up ones, aren't they? Okay, yeah, let's do these ones really fast. These ones are nothing special, just straight up. Let's do them super fast. We have the included angle in both, so it's not very exciting. So A equals a half.
You know, I made my because.
Owen, what's the answer?
Poor Owen.
What's the answer? 8.4. I don't know either. 25.37. What's our unit spell at?
Square.
Yeah, good. Yeah, we're probably a bit rusty on our unit using, because we haven't really dealt with shape and space for a while, so we might be a bit rusty with our units. So about 25.3 for that one.
Is it a rhombus just like a diamond?
Yeah, it's specific. Yeah, it's specifically a square. What's special about a rhombus and its diagonals?
They're perpendicular.
Yeah, they're perpendicular, yeah. So if you put the diagonals in, they split the rhombus into 4 equal right-angled triangles. So that's where we're going to be able to do some stuff, but maybe we don't need to do it that way. Maybe we just need to split it. Yeah, because it's non-right-angled. I'm thinking Python.
But you don't technically have to. You could just do A, B, sine, C, because you don't, if you're multiplying by 2 and then dividing by 2, it's just...
Yeah, well done. Good, yep. So, so you guys also see on the next page, we have the included angles. Oh my goodness, what's sine 30? This is an opportunity that I can't resist. I need to do the, I want to revise this. The 30-degree one. So the 30-degree one, oh gosh, 30 degrees would be here. So do you remember the other special triangle? 30-60 degree one? Yeah. So which one of those three sides is the shortest side? 2, 1, and square root of 3. 1, yeah. So 1 would be
Opposite one.
yeah, opposite the side. That one, yeah, good. And the longest side is the hypotenuse, so it's 2, yeah? Yeah, good. So this is just an opportunity to revise these lovely little special triangles. Because, and then what would sine of 30 be? Sine of 30? Half, yeah. So that's why we end up with a nice little, that's why we've ended up with a nice whole number. Because sine of 30 equals a half.
Why do we need to know these? I guess it's not necessary. We can just use on calculator.
Oh, because you've got a non-calc paper. And this stuff, this could have been on a non-calculator paper. So just showing you, yeah, this is, for example, this could have easily been on a non-calculator paper, in which case you would have to be able to work out what sine 30 is using the special triangles. And then you would just sub in a half here, and a half times 8 is 4, 4 times 7 is 28, 28 times a half is 14. Yeah, so that could very easily be a non-calc. So maybe just assume that that would be a non-calc question. It's okay if we do it first to begin with, as calc, but then in hindsight I would see that as a non-calc question. So that's why that one's quite nice. Okay, now onto some good problem-solving ones. Is this the last page? Yeah, it is good. Okay, then we've finished this, and then you can work on the assignment or the textbook exercises, whatever you prefer. So, yep, so you've talked about a rhombus. As Katie said, is a slanty square, a square that just went zoom. And an angle of 68 degrees. Find the area of the rhombus. You might like to draw a diagram.
A diagram?
Yeah. That's meant to be rhombus. So bad. Ah, give up. Okay, I'm going to do it on here because it's too difficult. Hey, no, I can't insert shapes. Can I do that? Is there a rhombus here? No. Is there a rhombus there? Ah. No, that's not going to work. Okay, give up. Okay.
It's like the orange square with the circle in the shape, yeah. And then you put the arrow that's like
Ah, yes. Yeah. Look at that. Is that pretty? How's that look? But see, on mine that's perfect, but on yours it's stretched because of the. I'll try to make it so it's not so stretched.
It looks fine.
Yeah, on mine it's it's compressed that way compared with what you see on there, because the projector stretches things a bit that way, a bit vertically. Da, da, da. Now we have a rhombus. Let's put the sticks on it to show it's a rhombus. Nice. So we've got side lengths of 14, so that means we've got 14, and we've got a 14 going on here. The others are obviously 14 too. And an angle of 68 degrees. Which one? Do you think this one's 68 degrees?
I just put anyone.
To be honest, you could. But 68, is that an acute or an obtuse angle?
Acute.
Acute, yeah. So just make sure you pop it where the acute one is, because it just makes a bit more sense. 68 degrees. And then I was saying, like, if it was done non-right angle triangle way, you could do it because the diagonals split a rhombus into 4 right angle triangles. But let's practice our non-right angles and just, like Grace suggested, split it down the middle instead. And then we've got 2 thingamajiggies, non-right angle triangles that we can just find the area of by using the area formula, because we've got the included angle with the 2 sides, and then just not to forget to double it all. I could very easily work out the area of one triangle and forget to double it. So you could maybe just want to either make a note to yourself somehow, double the area at the end, like make a note to yourself, or you could do 2 times and then a big bracket if that helps. A half. Sine 68 is not from a special triangle, so we need to use calculator. So whichever way you find stops you from by accident just finding the area of one of them and not the whole rhombus. You might just make a note, you might just really, really try hard to remember. And then as Bella said, if you wanted to, 2 times a half is just 1. So you could do 14 squared, sine 68. What is 14 squared?
196.
196, yeah. So overall it's going to become 196. Sine 68, you don't have to, you could have just gone straight to putting it in the calculator from my first step, that's also okay. Just thought that's kind of fun stuff to see. 2 times a half just cancels out to 1. 14 times 14 is 196. What's our answer in the non-rounded sense?
181.
181?
72. 80358.
So that's it. See how we're disciplining ourselves to write out the unrounded. That's because it's a hard thing to do. Sometimes you're just so tempted to write the rounded. So we're trying to make this a bit more naturalised, so it comes naturally in an exam position. And is that 181.87?
No.
Yeah, it's 182
centimeters squared.
centimeters squared is an area. And keep an eye out as well, just double check. I will always have to look at the end, just see if they threw a little sentence at the end, round to 1 decimal place or anything sneaky like that. That's pretty common too, that they might tell you what's around, and then after doing all this work you forget to go back and check it. They might have given you a different rounding instruction. So that's pretty nice, that one. A different one, a parallelogram. You can use a nice drawing tool again. Those side lengths. Is this pretty much the same thing?
That's what I thought. Isn't it kind of like that?
Oh, it's in, yeah, it's just, so the only difference is that the side lengths are different, but I think that's the only difference really. Let's do this thing again. Let's exaggerate it a bit. Parallelogram. We've got side lengths 5 and 9. And an angle of 47. Is this the one 47? No. It's the acute one. So if you happen to be asked to draw a diagram and that was worth a mark, just make sure you put the angle in the one that makes sense. In the acute area, if it's an acute angle. And you probably just did it like this again, did you? Split it and then double. So I kind of just doubled this up. And it's not a special triangle, so this would be a calculated problem. You don't need this little step, I just simply do it. Just to point out that 2 times a half just cancels down. So if you see that in a non-calc equation, you can do that. What's our unrounded answer?
32.9116.
Lost it.
32.9.
Do we have any? Oh, we do. Do you have any space down the bottom? If you've got, don't worry if you don't have space. I just thought I haven't shown you one where you need to solve for an angle. It is just transpose as normal. But I'll just quickly make one up. We did have one where you had to solve for a side. So if area, what do we make the area? Something like, let's make it 900. Squared. What else do we say? A equals 40. A equals something nice. 3 cn. C equals 6 cn. And big angle. Oh no. Solve for angle B. So find so they could just say angle B or find ABC, that kind of thing. So if you've got any space, maybe draw it, but if not, you can just watch it. And assume it's a triangle. I forgot to mention a triangle. So let's draw a non-angle triangle. A is 3, C is 6. So it's not drawn to scale, of course. 3, 6. So if that's A, that's angle A. If that's C, that's angle C. So angle B must be up here. So the good thing is it is the included angle that we want.
What is it?
Well, that's a 3 and a 6, just following these things. So the one thing, the good thing about drawing it is you're double checking that it is the included angle. And if it is the included angle, you can use the area formula. So we do want the included angle. So let's plug all that in. So the area is 900 equals. Sometimes I forget the half as well. Another common mistake is forget that there's a half at the front. 3, 6. Sine B.
On C, B.
Oh yeah, I made a B this time.
Oh,
Yeah, because the included angle this time is B, because I gave you side A and side C, and so the included angle is B. Notice you have a combination of all 3 letters. If you have AC, it should be B here. If you have BC, it should be A there. You should in total have all 3 letters. The main thing is it just has to be the included angle between these 2 sides. That's what has to be over with the sign. Let's try to maybe, how would you start to do this kind of non-calc to begin with? Which way, some people might work out some of this first, some people might times by 2. Do it whichever way you like.
We just do 6 times 3 is 18 times a half is 9.
Yeah, okay, sure. So, let's do that if you want, 900. Half times 3 equals 9. Sine B. And then we could do with sine B by itself. Divide by 9 is just 100, yeah. And then how do we start to get B by itself? Good, yeah.
I did that and I got error.
I probably came up with a stupid triangle. Yeah, so yeah, you can get. I could probably come up with an impossible triangle or something.
Nice.
Oh, really? Did anyone else get like error? Did you get a number?
There is not
An error? Okay. Oh yeah. What should I? Maybe it's the.
Oh man.
Yeah, there are such things as impossible triangles. Let's see. I'll just see what happens if I change the numbers, and I'll just slightly might change one number. Like maybe I'll make 3 7 or something instead. Okay, so if it was 7. What can I make it? 10 and 6. I can make it 10 and 6, which would make it 30. 900 divided by 30. Oh, okay, that's better. I think it, so don't worry, you don't have to change too much. If I just change the 3 to a 10, I think we get a better question, because I made it up spur of the moment. I've made a dodgy triangle. So let's change our 3 to a 10.
Doesn't the hypotenuse have to be along the side?
Yeah, that's what I thought.
That was if it was a right angle triangle. That's a
Okay,
good point.
sorry,
Yeah, if it's but yeah, it's good that you're thinking about things like that. Like why isn't it working? But yeah, I must have made an impossible triangle somehow. Okay, so 900 equals a half 10 times 6, which would make it 30. 30, yeah. And what's 900 divided by 30?
It's like
30. Yeah. Change that.
yeah, 30.
So let's say 30 equals sine B. Hang on, does it work? Let's see. Did I check that? It doesn't work? I didn't calculate.
I think this is all we do.
Oh yeah, I forgot it. Okay, let's just move on. But yeah, anyway, so you would sine minus 1, that kind of thing. I'll just pause it maybe, rather than put Calvina through the pain of watching all this. So we can see now what I've done as a mistake. So for one thing, sine of theta should be opposite over hypotenuse. And as the hypotenuse of a right angle triangle is always the longer side, opposite over hypotenuse should be a fraction. And so a number less than 1. What I have done that is bad is 900 is an impossible area for a triangle with side lengths of 3 and 6. It's impossible to get. So really I need to bring my area down, don't I? What should I take it down to? It's not undoing. Stick on. So area, should we make the area something smaller, like 3 and 6? What could our area end up being? So we need to be able to divide it by, what was it again? Divided it by 18, was it? Half 3, 6, no, divide by 9. So divide by 9, our area should be something less than 9. So an area less than 9, maybe let's make it something like 8. 8 cm squared. And the triangle's still the same. So then we've got something like 8. Get a nice number now. So sine minus 1, second sine, 8 divided by 9. Oh my, we get an answer, good. That angle ends up being 62. Sweet. Okay, so that was a question made up on the spot.
So we're back to 3 and 6.
Yeah, 3 and 6. My error was that, which I didn't even think of the fact that 3. If you got a length of 3 and a length of 6, it's impossible to have a triangle that would have a 900 centimeter squared area. And the reason why sine wasn't working is sine B, or sine of any angle, should always be a number less than 1, because the opposite always has to be shorter than the hypotenuse. So that's why my triangle didn't work. Problem with making things up spur of the moment. It's good to see why it didn't work. Yep, so the hypotenuse has to be longer than the opposite side. And now it does work. And now you can have time working on the assignments, or textbook exercises, or of the like. Does anyone not have a copy of the assignment? Because I've always got a few spares. Sure thing.
Do you mind if I do something for the